Welcome protein coders, let's build some coding muscles. Earlier we studied how to build a segment tree and also to perform an update query. Today we're gonna see how to range some queries in a segment tree. Suppose I want to find the sum between ranges. Okay, so let's see. Here is our segment tree and we need to perform the range sum query between the index 2 and 4. Means I need to find the sum between the index 2 and 4 via our segment tree. So the first node of the segment tree is of range 0, 5, right? 2, 4 is completely inside 0, 5 and we don't know, right, what to return. So the root node will call for both of its sides. It will move left also and right also. So let's first move left and we again compare. So again it's similar case, right? 2, 4 and 0, 2 are overlapping, but we still don't know what to return exactly. So we will again call for both of its children. So here you see 2, 4 is completely non-overlapping with 0, 1, right? They're completely non-overlapping. So from here we will return 0. And in the second case, 2, 2 is a part of 2, 4. Right, it is inside the range of 2, 4. It is inside our query range. So we will return the value 7. That we find some portion of the sum. Okay, some portion of the range sum. And we will return 7 to the root. Similarly, we will move to right. 2, 4 is partially overlapping with 3, 5. Right, it is inside 3, 5. So again, we will call for both of the sides. And in left side, if you see 3, 4, this range node is inside 2, 4, right? It is inside the query. So we will return this 5 from here. And on the right side, 5, 5 is completely non-overlapping with our query range. It is outside range 2, 4. So we will return 0. And at node 6, 5 plus 0 is returned. And finally, 5 will be returned to root node. And at the end, we will have 7 plus 5 equals to 12. As our final query sum. And if you check in our vector also, so 2, 4 is having sum 12. Okay, so we performed 3 simple steps. If you observe carefully, let's see it in the code. How we gonna implement this? Let's see. So let's have our function query. It will have start and end index. These are the starting and end index of our query. And then I, L and R, where L and R are the starting and ending pointers to our vector, right? The range, and I is the index in our segment tree. Now, first case, if L is greater than end and or R is smaller than start, that means they are out of bound. L and R are completely non-overlapping with the start command, so we'll return 0. Second case, if L is less than equals to start and end is less than equals to R, then we will simply return the node at that segment tree, at that index. These are the cases when we are completely inside the query range, right? Or else what we will do, we will calculate the mid and call for both of the sides recursively, right? First, we will call query for left side and we will change the index 2 into I plus 1, L, mid. Similarly, we will call for the right side also. The first case is for the non-overlapping cases. Second is for completely when L and R are completely inside the query range, start command. And third one is for partially overlapping. We will call for both left and right side. If you see, let's query for 2, 3 range, right? So in worst case, you have to go to the bottom of the segment tree twice. So it will, the time complexity will be approx log n plus log n. So it's approximately log n times, right? Which is a great improvement if we used a prefix sum, right? In that the updation query is taking n times, right? Query is faster, but updation is very slow. But here both updation and queries are can be performed in log of n time. So that's all from my side, guys. If you have any questions, please mention them into the comment box. I hope this helps. Keep practicing, keep smiling. Thank you.